All right, we're trying this again. Hopefully it works this time. Oh, last time I messed up multiple times. Hmm. This time I'm hoping it doesn't flum on me. Flummy. Um, yeah, so this section is officially done. So yeah, let's just do an overview now because I made like two videos about the last part and I failed two times and I'm not gonna do it again. I'm just gonna say that was a success and move on. Basically, that's the plan. And we're just gonna move on over here, I think. As my tablet runs, we're going to do an overview of 1.1. And let's start on 1.2, basically. And actually, I'm gonna work on something else after this. So I'm not even actually gonna work on this after for a while because I have other responsibilities. There are other classes too, but the other classes I had to prep for, but no, that doesn't make sense. Does it? No, it does make sense. But actually, probably should. Hmm, I don't know. Um, yeah. So I also have to figure out what the textbook for MAE to yeah, it doesn't matter. I don't need to say it. We'll just we're just gonna continue this. So I start off uh chapter 1.1 with because I'm done with chapter 1.1 with my textbook finally with addition. And as you know, I love to yap, subtract, multi, and so on. So the first thing I say is Arabic numbers. That is 1, 2, 3, 4, 5, 6. That is what we use in this country. And then with that said, we can represent numbers as 1 as 1, 2 as 2, and I use some weird circles with it, which I don't even know what that is. I just choose that because it looks like coins, basically. And we have a huge array of numbers here. Now, here's why I choose to represent number line. So we're going to choose a human because the positive time is chosen by human. So this is positive direction. This is the negative direction. And we choose the reference point. That's all we kind of do. Yeah. And that's how we get negative numbers. We just chose a reference point that usually causes a negative number. Sometimes it's not that, but sometimes it is. In physics, it usually is. And then zero is like the null value, because it literally just deletes or does nothing, or uh, it's very valuable for steady state. Like without zero that the Indians created, we wouldn't have a lot of the calculus or anything as we have right now. Now, next thing I did is I walked the cat 10 minutes earlier. Now, 10 minutes earlier is 600 seconds. So I just put a negative sign there as a reference point, and we keep on going on. We did a little bit of relative speed, but it really doesn't matter. This one is the dog is moving 5 meters to the right. Oh gosh, I don't like this. Well, I'll use vectors. I don't like the vectors. Maybe I should have done, but very simply, it's just 2D direction. Up, and then we keep on doing numbers. Honestly, yeah. And the multiplication here, we start doing the double negatives, and then we do square roots. So I'm just gonna skip through these because they're kind of boring. And I already did them in previous videos or something. I did change this. I think I showed a video of it because I didn't like the original one. So instead, we are doing this where we're just showing how divisions kind of work, um, and how there can be multiple ways to get this. And as you can see, there's two, three, and there's one. There's like a final three residue over here. And you can see there's a GC greatest common divisor that is 6 over here because if sorry, if it's 18 and 12, then it's 6 because it's this, but well, okay, so yeah. The idea of 0 multiple times because 0 is important, and how a number divided by 0 equals infinity, which is diverging, which means it does not exist. Yeah. A, a 0 divided by a number is possible. Just means there's nothing there. Long division. Um, why did I this is off? Let me experiment that. Much better. We got different numbers. Irrational numbers is the most. Actually, thinking about it, we could do a proof on why square root of 2 is irrational. Fully no, but I could do it. We went to properties, and then we went to tens. We went to even odds, and then find absolute value. No questions that we already found before. And here is GCD. If A equal 12 and B equal 18, okay, we can claim that this is 2, 6, 2, 3, and this is 3. I mean, we can do 2, 9, 3, 3. We can get 6 over here and 6 over here from these two. And then we can just say, okay, the GCD of these is 6. And then there's many multiple common divisors. I did that multiple times, and I'm hoping I don't have to do it again. I'll go down to the next one. We'll do least common next, LCM, but n equal 3, 4, 5. And then we just because we chose a equal 4 and b equals 6, because I tried to do it with 12 and 18, but it becomes really big. I'll show you later. Yeah, and then an bn gives you a array of 8, so on, and then we get 6, 12, so on. You can instantly get 12 as the first one. And over here, after that, uh, okay, maybe over here. I'm running out of how those goes. Well, it's fine. I'm tired. This is my fourth video that I keep on messing up. But it doesn't matter because no one's watching. Luckily, I'm glad that no one's really watching so far. So GCD next, which is what you get equals D. We choose D, and then we see AB. Last time I tried to describe this, I failed miserably because my camera wasn't on, so whatever. We get this format. Notice that this is a composite. This is a composite of that. Now, what that tells you is that if A prime and B prime gets this format, because this is a GCD of 1, we know that A prime and B prime from this needs to be in the common multiple. Otherwise, you can't get anything because common multiple is a multiplication of the integers. So they must exist, basically. The composite must exist with the GCD. So what that gives you finally is that A prime D B prime must equal LCM, basically. Oh, does that show? over here. So LCM must exist. Therefore, that's how you get LCD. And as you can see, if I choose A equal 36 and B equal 14, that's way too large, and it's easier for you to just call on this equation and say, solve it like this, like that. That solves the whole thing like snap. That's the recommended way, in my opinion. Um, and then we go into prime numbers over here. And the whole point of this I over here is just multiply, but there's less prime numbers as we go along. That's the whole entire point of this whole thing. Did I do this right? Something seems okay. That's fine. Let me see. I want to do this actually. That's fine. I don't care. So the prime numbers gets increasingly more less static. Basically, there's less as you go further in the number. As you can see over here, there's a lot over here. There's a lot over here up to 50, but then after 50, it becomes less and less of the prime numbers. Um, you can see by concept. Also, fun fact: if it was p plus one, you would get an even number. Therefore, there would be no primes. So if you get a question that says because there's only one even prime pair, which is actually okay. I take it back. I'm wrong. I'll tell you why I'm wrong. So two is the only. Oh, okay. Two is the only event on my tablet didn't work again, so I'm gonna do load. I hate my tablet sometimes. Anyway, I was about to say before my tablet decided to scatter that two is the only even prime. So actually taking one is also a prime too. So one plus one. So there'll be one prime if you said p comma p plus one. If I said this, if I said instead of that question, okay, my computer is kind of working now. If I said get me um p equal prime number, find all, where am I writing? Oh, here. Ah, okay, maybe not so. Okay, let me be a little bit more like reasonable. If I said assume p equal prime number, find all prime pairs in the order of p comma p plus one with, it doesn't really matter because as you know, there's only one even prime, which is two. So then p must equal one, and it's p comma one plus one comma two, which means that there is one prime. So that might be a good question to put. Um, anyway, there's Euler's equation, so the ratio of a circle and the golden ratio. That's an interesting question. I wonder if anyone, not a lot of what we knew. I might want to make that a question here. Anyway, I'm done. Oh my God.